So dear students, the next experiment what we are going to see here is about encoders and decoders, which is experiment number 4. Let me go here to the syllabus. Your syllabus experiment number 4 is encoders and decoders. So you have to understand what is encoding and decoding. Encoding is changing the signal and decoding is recovering the original signal. Your encoding means you are adding some other signal along with it, and decoding means you are removing the added signal and you are getting the original signal. Yes, so here let me see how are we going to do this encoder and decoder. It's very simple. So the circuit diagram of encoder is this. So the circuit diagram of encoder. So if I'm going to send a signal, so these are my data lines which is available, and when I'm going to send the signal over this data line, according to that data line my data will be encoded. Suppose for example, if I'm going to send data through 4, then what it will be encoded here is you'll get it as 100, which means that fourth data is available, so the encoded version of data 4 is 100. If I'm going to send data through 7, then it will be 111. So that is what we are going to realize in this circuit. So we are going to form a truth table. According to this truth table, I am going to implement my circuit. So these are my data lines. So when all the data lines are 0, no data will be selected. All your outputs will be 0. When the data line, you can see here, yes, so if you have got an enable pin, so that enable pin also can be used over here. In this case, so what happened here, this data are not present. Actually this should be, when this is 1, yes, your output will be equal to 1. Yes, so what will happen here, when this is 1, 7th pin is 1, your output will be 111. When 6th pin is 1, your output will be 110. When 5th pin is 1, your output will be 101. When 4th pin is 1, your output will be 100. When 3rd pin is 1, your output will be 011. When 2nd pin is 1, your output will be 010. When 1st pin is 1, your output will be 001. When D0 is 1, your output will be 000. Okay, so these are my input and these are my output, what you have to get over here. So what you have to understand, when data is present in the 3rd pin, you have to get an output of 011. So that is encoding. Your data 3rd pin is available, so that data is encoded and present as 011. Yes, so now we will be doing a K-map for this and for this and for this. When you do the K-map, and the resultant of your K-map will be this. Or you can directly write out the expression. You can see here A is present when your D4, D5, D6 and D7 are present. So the summation of D4, D5, D6 and D7 is A. Okay, so that is what put over here. B is present when you can see when D2 and D3 is high, and when D6 and D7 is high. So D3, B is present when D2, D3 is high, D6, D7 is high. When you sum up all these 4, you can get it to be B. Similarly for A and for C, we will be writing out the expression, and that is realized with the help of a circuit. Yes, since it is addition, you have to use OR gate here. OR gates will be used and its output will be justified. Now the same is simulated in PROTEUS software. You can see here I have taken data lines, 7 data lines, 8 data lines are taken over here, and from these 8 data lines, the same circuit whatever is present, so 1 2 3 4 5 6 7 8 9, 9 OR gates are used. 1 2 3 4 5 6 7 8 9 OR gates are used, and the output of the last OR gate is given to your LEDs. Now you can see that whenever I change my data pin, accordingly my output will be changing. So let me check it over here. Let me give the data pin as 7. So you can see all the LEDs are glowing, which means that 7th pin is available, 7th data pin is available, so it is 111. Now I remove this, I give it as 3. So your data is 011. So what you can see, 3rd data is available, your output is 011. Now I make it as 0. When 0 data is available, all the LEDs are 0. So no, it means that 0th data pin is present. Now let me take it as 6. Yes, 110. So 6th data pin is available, it is 110. Similarly, you can check for all the data pins and you can see that whether the circuit is working or not. Try to build the circuit in PROTEUS and check whether the circuit is working. So this is about encoders. The reverse is the decoders. Let me stop it over here. We will go to decoders. So decoder is, you will be having the signal as 111, 110, and that will be decoded and signal will be sent to that data pin. Okay, so that becomes decoding. The circuit for decoding is over here. So here I have built a decoding circuit for a 2-bit. So 2-bit in the sense 00, 01, 10 and 11. So for a 2-bit version I have built a decoder, and here when 00 is present you will have an output at D0. When 01 is present you will have the output as D1. When 10 is present you will have the output at D2. When 11 is present you will have the output as D3. So that is what a decoder is going to do. You will be writing out the truth table for this, and when 00 is present, D0 will get your output. 01 is present, D1 is getting your output. 10 is present, D2 is getting your output. When 11 is present, D3 is getting your output. The same is realized in PROTEUS software. Let me open the PROTEUS software here. It is decoders. It's very simple. Yes, so you can see the decoder circuit. Now let me run the simulation. So when both your inputs are 1, when both your inputs are 0, 0, 0, your first LED D0 is glowing. When 0, 1, D1 is glowing. 1, 0, D2 is glowing. 1, 1, D3 is glowing. So it is checked. Whatever is the data, encoded data that is available, that encoded data will be decoded by this decoder circuit, and it will be fed to the corresponding data lines. Okay, so this is all about encoders and decoders. Try to work it out, understand and simulate and check it out whether the circuit is working properly. That's all for this experiment. Thank you so much.